Hello all, today in this video I am going to show and demo for artificial neural network with the ntrf optimizer. Previously with the same dataset and the same artificial neural network, we have worked with some other optimizers and have made a comparison. With the same code we are at ntrf. So for that, initially we are importing the libraries what we are needed, and then we are just loading our data set. This data set we downloaded from Kaggle. You may just click the heart disease detection data set. Kaggle means you will get this data set. It will have nearly 14 entries. Among that, the first 13 entries we will be using as the x variable, and the last one, which is the target one, we will be using as the y variable. And then we are getting the info of the data set. From that we are getting that everyone are integers, but the whole peak is only the float one. Then we are describing our data set. Then we are just checking whether our data set is having any null entries, because if it is having any null entries means we have to work with some pre-processing functions. Then we are displaying the heat map of the data set. Then we are making to display the x variable and y variable. The x variable, as I said, we are dropping the target variable, and all the others like or it becomes the x variable, and in the y variable we are choosing only the target one. And based on this x variable and y variable, and the test size as 0.2, that is 20% for testing and remaining 80% for training, we are determining variables like x train, x test, y train, and y test. Then we are using the standard scalar to convert to vectors, the values to vectors. Here this is done with x train and x test variable. And then we are getting the shape of the x train. Why? Because this shape we will be using with the output dimension, or sorry, input dimension. Then we are determining the shape of our ANN. It is having a sequential layer and 3 dense layer. In the first 2 dense layer, the output dimension is 11, and the last dense layer, the output dimension is 1. Because why? Because our work is a binary classification work. If we are using multi-class classification means this one will be replaced by the number of classes which is present in the data set. Then all the 3 dense layers use the kernel initializer as uniform. Then the first 2 dense layer use the activation as ReLU. The last dense layer use as sigmoid. Then the input dimension is 13, which is the dimension used from the data set. Then first we are working with the Adam data set. Optimizer, loss is binary cross entropy, and metrics as accuracy. Then we are using the early stopping. Early stopping, here by early stopping we are meant to monitor validation loss. Apart from validation loss, you can also choose some other parameters like accuracy or validation accuracy or loss. But we have chosen a validation loss, and for 10 approaches it will just check whether validation loss is not taking any actions. And if it is not taking any action means it will just move to patient move with stop its execution. And for 10 approaches, why 10? Because patients we have given us 10. If you want some less number of approaches or higher number of approaches means here you can change this patient's value. Then we are just training our data set by using classifier, by using the fit function, and with the help of variables x train, x test, validation data approaches as 50. And we are also calling this early rate, early stopping. With this adam optimizer, this call early stopping is not making an action, and it is just run for nearly 15 approaches. Then we have got displayed the classification report for and got the values of precision, recall, F1 score, and support. And the accuracy here you may notice as 91. Then we are plotting the making a definition to plot the confusion matrix, and as per that we are plotting the confusion matrix for every optimizer. This is the confusion matrix for Adam. Then we worked with SGD. All the layer compositions are same only. The only difference it will vary is the optimizer. Previously it will be Adam, now it is SGD. Here this early stopping is made that action, and so it has ended with the approach 11. Why? Because here you may notice that this validation loss is not showing much difference. You may notice that only zero point 0.1 or zero point 0.2 difference is found with this validation loss. So this is making its execution, stopping its execution by approach 11, and the accuracy is displayed as 48. Then the confusion matrix is also plotted. Next comes the optimizer. Here cross entropy, cross early stopping is not made its action. Then the class accuracy is 90, and confusion matrix is made. Then comes the adadelta optimizer. Here you may notice the accuracy and the confusion matrix. Then comes the adagrad. Here the accuracy is 48%, and here this early stopping has made its action, and since the approaches has dropped with 11 itself. Next the confusion matrix is displayed. Then comes the adamax, and here this early stopping has not made its action, and we have got an accuracy of 88%, and the confusion matrix is also displayed. Then the nadam we have worked with. Here also the confusion, the early stopping is not made its action, and the accuracy we have got as 90. Then this is the confusion matrix of it. Now in this code we have worked with the FTRL. The only difference, as I said, is this optimizer. In the place of the previous optimizer, we have to replace the optimizer which we are using it, and we are just making its execution. Here the early stopping has done its action, and it has approaches has stopped till 11, and this is the classification report value. And we have got an accuracy of 48, and we have also displayed the confusion matrix. Next we have made a comparison of all the optimizers which we have made so far. So this is the comparison graph we have got. Here you may notice that this FTRL, it is in pink color, and this is the lowest one among as of now. The nadam and adam is showing some better accuracy and also less loss, you may notice. So this is the details regarding this code. In the next video we will be working with some other optimizers. Thank you.